Video 21, Part 21B of 25, Inputs to the Perform Qualitative Risk Analysis process. The purpose of this video is to develop a WBS to present the inputs to the Perform Qualitative Risk Analysis process. The Perform Qualitative Risk Analysis process is the third process in the Project Risk Management knowledge area and is related to the Planning Process Group. Comment your city name, like, subscribe to my channel, and share with others. Thank you. How important is the input of project management plan to the PMBOK Perform Qualitative Risk Analysis process? This question gets to the heart of how the PMBOK guide processes are interconnected. The project management plan, especially its risk management plan component, is critically important and a direct input to the Perform Qualitative Risk Analysis process. It is not just a minor reference, it provides the essential framework, criteria, and context without which the analysis would be subjective and inconsistent. Here's a breakdown of why and which specific components of the project management plan are key inputs. Risk management plan, the primary source. This is the most vital component. Within the risk management plan, several elements directly guide qualitative risk analysis as follows. Roles and responsibilities. Defines who is involved in the scoring and analysis sessions. Risk categories. Provides the RBS or risk breakdown structure, ensuring risks are analyzed in consistent groupings. The risk breakdown structure, or RBS, is simply the skeleton or map that shows these groupings. It's a hierarchical list that, first, groups similar risks together. For example, technical risks, external risks, or organizational risks. Second, it provides a common language so everyone on the team understands what type of risk they're discussing. Third, ensures consistency by making sure all risks are analyzed using the same framework. To use an RBS is important because you avoid the apples and oranges problem. You're not comparing a technical glitch to a budget cut in a disorganized way, you're analyzing each risk within its proper context, which leads to better risk management decisions. A standard RBS is usually hierarchical, looking something like this: Level 1, the category, or the bucket. Level 2, the subcategory or the specific source of risk within that bucket. As example, consider a general construction or engineering project. This is the classic RBS structure often used in physical infrastructure projects. 1. Technical risks. First, scope definition risks. For example, incomplete drawings, changing requirements. Second, design errors or omissions risks. For example, flawed calculations. Third, technology or equipment failure risks. For example, crane breakdown or software bugs in automation. Fourth, site conditions risks. For example, unexpected underground utilities or soil contamination. 2. External risks. First, regulatory or legal risks. For example, permit delays or new safety laws. Second, weather or nature risks. For example, floods or extreme heat slowing concrete pour. Third, market or economy risks. For example, sudden steel price increase or labor shortage. Fourth, subcontractor default risks. For example, vendor goes bankrupt. 3. Organizational risks. First, resource conflicts risks. For example, key engineer pulled to another project. Second, funding or budget risks. For example, delayed internal payments. Third, prioritization risks. For example, parent company shift strategy. 4. Project management risks. First, estimation errors risks. For example, timeline was too optimistic. Second, communication risks. For example, miscommunication between night and day shifts. Third, planning risks. For example, unrealistic schedule dependencies. Risk probability and impact. These are the two fundamental dimensions used to assess any individual risk. Standardized scales, such as 1 to 5 or very low to very high, are established for both probability and impact. This forms the core of qualitative risk analysis. Let's take a short break to explain the risk probability and impact. Risk probability and impact are the core components of risk assessment. Regarding risk probability, we have the following explanation. This is the chance that a specific risk event will occur within a given time frame. It can be expressed in various ways, such as a percentage, for example, 20%, or a frequency, for example, once every 2 years, or a qualitative scale, for example, low, medium, or high. The main characteristics of risk probability are: first, measured on a scale, usually using a 1 to 5 scale or a low, medium, high scale. Second, the basis is determined through historical data, expert judgment, or statistical analysis. Third, limited in time, as it is defined within a specific period, such as probability in the next 6 months. The most common format for the qualitative scale is the 5-point scale. First, very low or rare, unlikely to occur, for example, less than 10% chance. Second, low or unlikely, could occur but is not probable. For example, 10 to 30% chance. Third, medium or possible, might occur occasionally, for example, 30 to 50% chance. Fourth, high or likely, will probably occur, for example, 50 to 70% chance. Fifth, very high or almost certain, expected to occur, for example, greater than 70% chance. Regarding risk impact, we have the following explanation. Risk impact is the magnitude of the effect a risk event would have on project objectives, such as cost, schedule, scope, or quality, if it were to occur. Impact can be measured either quantitatively, for example, a $50,000 cost overrun, or a 2-week delay, or can be measured qualitatively, for example, low, medium, or high. The main characteristics of risk impact are: first, the risk impact is multidimensional. Impact can affect various areas including finances, time, quality, reputation, and safety. Second, the risk impact can be positive or negative. While typically negative for threats, impact can also be positive, representing opportunities. Third, the impact of the risk can potentially be delayed. The consequences of a risk event may not be immediate and may manifest themselves long after the event itself. To ensure consistency, standardized measurement guidelines with clear definitions for each relevant dimension should be established. Below are examples using a common 5-point scale. As examples, the common impact dimensions and scales are: regarding financial impact, we have, first, negligible. In this case, we have minimal financial loss. For example, less than 0.1% of budget. Second, minor. In this case, we have small loss. For example, 0.1 to 1% of budget. Third, moderate. In this case, we have significant loss. For example, 1 to 5% of budget. Fourth, major. In this case, we have serious loss. For example, 5 to 10% of budget. Fifth, catastrophic. In this case, we have loss threatens project or organizational viability. For example, greater than 10% of budget. Regarding schedule impact, we have first, negligible. In this case, we have no detectable delay. Second, minor. In this case, we have slight delay. For example, less than 5% of total schedule. Third, moderate. In this case, we have delay affecting the critical path. For example, 5 to 10% of schedule. Fourth, major. In this case, we have major extension required. For example, 10 to 20% of schedule. Fifth, catastrophic. In this case, we have project deadline is unreachable. For example, greater than 20% delay or indefinite. Regarding scope performance impact, we have first, negligible. In this case, we have imperfections or barely noticeable, requirements fully met. Second, minor. In this case, we have a minor reduction in performance in a non-critical area. Third, moderate. In this case, we have significant reduction in performance, some secondary requirements not met. Fourth, major. In this case, the key primary objectives are not achieved. Fifth, catastrophic. In this case, the end product or service is unusable or fails to meet its core purpose. Regarding reputational or strategic impact, we have first, negligible. In this case, we have no public awareness. Second, minor. In this case, we have minor concern reported only within the organization. Third, moderate. In this case, we have negative local publicity, dissatisfaction among key stakeholders. Fourth, major. In this case, we have negative national media coverage, loss of key partners or stakeholders. Fifth, catastrophic. In this case, we have long-term brand damage, irreversible loss of public trust. Regarding safety, health and environmental impact, we have first, negligible. In this case, we have minor first aid injury, a very small, easily contained spill. Second, minor. In this case, we have medical treatment required, a contained environmental incident with no lasting effects. Third, moderate. In this case, we have lost time injury, localized but reversible environmental damage. Fourth, major. In this case, we have permanent disability to one or more persons, major release of contaminants. Fifth, catastrophic. In this case, we have fatality, irreversible and widespread environmental damage. Returning to the elements of the risk management plan that guide qualitative risk analysis, we have probability and impact matrix. The probability and impact matrix is a fundamental tool from the risk management plan used to guide qualitative risk analysis. It is a visual tool, often a grid, used to prioritize individual risks for further action. Essentially, the matrix combines the two main dimensions of a risk, its probability of occurrence and its potential consequences, to assign a priority rating. For example, low, medium, or high. The two axes of the matrix. The matrix is built on two axes. Y-axis or rows. This axis represents probability or likelihood. It measures the probability of a risk event occurring. In this case, the scales can be descriptive, numerical, or a combination of both. Regarding the descriptive scale, we can have, for example, levels such as very low, low, medium, high, or very high. Regarding the numerical scale, we can have, for example, levels such as less than 10% chance, 10 to 30% chance, 31 to 50% chance, 51 to 75% chance, or greater than 75% chance. X-axis or columns. This axis represents impact or severity. It measures the negative consequence if the risk event occurs. Impact can be measured against various objectives like cost, schedule, safety, or reputation. Like probability, impact uses a defined scale. For example, very low. In this case, we have negligible cost-time increase, minor inconvenience. Low. In this case, we have less than 5% budget, schedule impact, manageable issues. Medium. In this case, we have 5 to 10% impact, noticeable performance degradation. High. In this case, we have 10 to 20% impact, major client dissatisfaction. Very high. In this case, we have greater than 20% impact, project failure, or a major safety incident. How the matrix works. The matrix is a grid where the probability levels, in the rows, and impact levels, in the columns, intersect. In this matrix, you will first, plot the risk. For each identified risk, assign it a probability score and an impact score based on the defined scales. Second, determine the rating. Find the cell where the selected probability row and impact column meet. This cell contains a predefined risk rating. For example, low, medium, high, or very high. This combined rating is often called risk exposure or risk priority. This process transforms individual assessments of likelihood and consequence into a single, comparable priority level. Interpreting the results. Action based on rating. The matrix is typically divided into color-coded zones to visually represent priority levels and guide responses. Red zone, located in the upper right corner. This means that these are risks with high probability and high impact. These risks are classified as extreme or high priority. They are often referred to as intolerable or critical risks. They represent threats with a high probability of occurrence and severe, potentially catastrophic, impacts on an organization's operations, objectives, or safety. Yellow zone, located in the center. This means that these are risks with moderate probability and moderate impact. These risks are classified as medium priority. These risks represent a significant, but not immediate, threat to project objectives, requiring structured, ongoing management rather than immediate crisis intervention. These risks need to be documented in a risk register, assigned a specific owner, and reviewed regularly to prevent escalation. Green zone, located in the lower left corner. This means that these are risks with low probability and low impact. They represent risks with potential events that have a low probability or minimal impact and do not require immediate action, but need to be monitored, usually in a watch list in the risk register. They represent a deliberate and calculated decision to accept the risk, since the cost of mitigation usually outweighs the potential impact. The steps to construct and use the matrix are as follows. Identify risks. Brainstorm and list all potential risks to your project or objective. Define the axes. Establish clear scales for probability and impact that are tailored to your specific project or organization. Assess each risk. For every risk on your list, determine its probability score and its impact score. Plot and prioritize. Locate the intersection of the two scores on the matrix to find the risk's overall rating. Use this rating to decide which risks need immediate attention and what type of response is required. Stakeholder risk appetite. influences the thresholds for what is considered a high-priority risk. Other relevant management plans within the project management plan. Scope baseline. Understanding project deliverables, constraints, and assumptions is crucial to assess the true impact of a risk on project objectives. Schedule and cost baselines. Risks are evaluated based on their potential impact on time and budget. The baselines provide the context. For example, a 1-week delay is low impact on a 3-year project, but high impact on a 1-month project. Quality Management Plan provides criteria for assessing risks related to product quality and compliance. Stakeholder Engagement Plan identifies key stakeholders who should be involved in the risk assessment workshops due to their influence, expertise, or perspective. How can an inadequate analysis of the project management plan harm the Perform Qualitative Risk Analysis process? It gets to the heart of how project management processes are interconnected. An inadequate analysis of the project management plan fundamentally undermines the Perform Qualitative Risk Analysis process, leading to a flawed, incomplete, and potentially dangerous risk assessment. Here's a breakdown of how each major component of the project management plan, if poorly analyzed, specifically harms the qualitative risk analysis. 1. Inadequate analysis of the scope baseline, comprised of the scope statement, work breakdown structure, and WBS dictionary. As a result, this leads to missed risks and an incorrect assessment of impact. Why does this happen? The work breakdown structure is the fundamental tool for identifying risks at the work package level. If the scope is not well understood or the work breakdown structure is incomplete, it is not possible to systematically ask, what could go wrong with this deliverable or activity? Risks associated with missing elements in the scope are never identified. Furthermore, the scope statement contains constraints and assumptions. Unvalidated assumptions are one of the main sources of latent risks. 2. Inadequate analysis of the schedule baseline and schedule management plan. As a result, it may provide incorrect probability and impact scoring, especially regarding schedule risks. Why does this happen? The qualitative risk analysis uses probability and impact scales, for example, 1 to 5. If the schedule is not analyzed for critical paths, dependencies, and float, you cannot accurately judge the impact of a delay. A 2-week delay on a non-critical task is low impact. The same delay on a critical task is high impact. Missing this context leads to misprioritized risks. 3. Inadequate analysis of the cost baseline and cost management plan. As a result, this leads to incorrect financial impact assessment and poor prioritization. Why does this happen? Without a clear understanding of the budget, contingency reserves, and cost controls, you cannot accurately assess the impact of a risk in monetary terms. A $10,000 overrun is catastrophic for a $50,000 project, but minor for a $10 million project. Inadequate analysis means financial impacts are guessed, not derived from the plan. 4. Inadequate analysis of the quality management plan and quality metrics. As a result, this can lead to a failure to identify technical and quality risks or to an underestimation of their severity. Why does this happen? If quality standards, metrics, and processes are not clear, the risks related to technical failures, rework, non-conformity, or customer rejection cannot be adequately assessed. What is the impact of a low-quality delivery? The answer depends entirely on the quality criteria defined in the plan. 5. Inadequate analysis of the resource management plan and resource calendars. As a result, this can lead to missing key resource-based risks and misjudging their impact. Why does this happen? Without knowing the availability, skills, and allocation of team members, or human resources, and equipment, or physical resources, you cannot identify risks like overall location, skill gaps, or equipment failure. The impact of a key person leaving is directly tied to how uniquely skilled they are and their role in the plan. 6. Inadequate analysis of the stakeholder engagement plan. As a result, this can lead to the omission of stakeholder-related risks and an inadequate assessment of risk tolerance. Why does this happen? This plan identifies key stakeholders and their influence, interest, and risk appetite tolerance. If not analyzed, you may A. Ignore risks arising from resistant or influential stakeholders and B. Incorrectly prioritize risks from the project perspective, to the detriment of stakeholder tolerance, for example, overestimating a low-impact risk related to an influential stakeholder. 7. Inadequate analysis of the requirements documentation and assumptions log. As a result, this is the main source of missed risks. Why does this happen? Unverified assumptions are, by definition, risks. The assumptions log is a direct input to risk identification. If it's not rigorously analyzed, these latent risks never surface. Similarly, ambiguous or conflicting requirements are major risk triggers that will be missed. 8. Inadequate analysis of procurement plans and agreements. As a result, this can lead to missing external and third-party risks. Why does this happen? If vendor delivery schedules, contract terms, or performance criteria are not analyzed, you won't identify risks like vendor default, late delivery, or cost overruns from change orders. The impact of a procurement risk is defined by the contract's role in the overall project. In conclusion, the project management plan is the guide for qualitative risk analysis. It provides the predefined rules, which are scales, matrices, and categories, that transform a subjective discussion about risks into a consistent, repeatable, and auditable prioritization process. Without the guidance of the project management plan, qualitative risk analysis would be, first, inconsistent, as different team members might use different scales. Second, subjective, since prioritization would be based on personal opinions rather than agreed upon project standards. Third, untraceable, as decisions about risk priorities could not be logically linked to defined project criteria. Fourth, ineffective, as it would fail in its main objective, which is to prioritize risks for further analysis or action in a way that aligns with specific project constraints and stakeholder tolerance. In summary, the Perform Qualitative Risk Analysis process relies on accurate project information to assess and prioritize risks based on their probability and impact against project objectives. The project management plan is the primary source of that information. An inadequate analysis of it means you are not assessing risks against the actual project constraints and baselines, but against an incomplete or incorrect understanding of them. This violates the very purpose of the process, which is to focus the team's attention on the risks that matter most to this project's success. Overall consequences of an inadequate project management plan analysis. First, garbage in, garbage out. Qualitative analysis is only as good as its inputs. A flawed project management plan ensures flawed risk analysis. Second, theater of risk management. The process becomes a paperwork exercise, creating a list that doesn't reflect the project's true risk exposure. Third, ineffective risk prioritization. the team wastes time on low-priority risks while high-impact, high-probability risks hidden in the plan's gaps go unmanaged. Fourth, loss of credibility. When unanalyzed risks from the core plan materialize, the risk management process is seen as useless. Fifth, project failure. Ultimately, the project is blindsided by issues that should have been identified and assessed early, leading to budget overruns, schedule delays, and scope failure. How important is the input of project documents to the PMBOK Perform Qualitative Risk Analysis process? The input of project documents is critically important to the PMBOK's Perform Qualitative Risk Analysis process. It is not just an input. It is the primary source of data upon which the entire analysis is built. Qualitative risk analysis is about assessing the probability and impact of identified risks to prioritize them. This assessment cannot happen in a vacuum. Project documents provide the essential context and specifics that make the analysis meaningful and tailored to your unique project. The main project documents and their respective values are presented now. 1. Risk Register. The risk register is the central document. It is the most crucial input. It contains the list of identified risks, all obtained during the Identify Risks process, which will be analyzed. The risk register provides structure. It may already contain preliminary information like potential risk owners, risk categories, and root causes, which inform the analysis. 2. Assumption log and issue log. The assumption log is important because unverified assumptions are a major source of risk. Analyzing the uncertainty and potential inaccuracy of assumptions is a core part of risk analysis. The issue log is important because existing issues can escalate or trigger secondary risks. It provides concrete data on problems already manifesting, which helps assess the probability and impact of related risks. 3. Stakeholder Register. The stakeholder register is critical for impact assessment. Understanding who the stakeholders are, their interests, and their influence is vital for assessing the impact of a risk. A risk that severely impacts a key stakeholder has a higher overall impact score. The stakeholder register is also important because it provides information about attitudes toward risk. It helps identify the stakeholders who should be involved in the risk assessment workshop, since their risk tolerance will influence the analysis. 4. Requirements documentation and project charter. The requirements documentation and project charter define what is important to the project, such as objectives, success criteria, key deliverables, and high-level requirements. A risk's impact is measured against these benchmarks. A risk threatening a core requirement or a strategic objective has a high impact. 5. Schedule and cost forecasts. The schedule and cost forecasts provide the scale for assessment. To judge if a risk could cause a 20% cost overrun, or a 2-month delay, you need to know the baseline, for example, a $100,000 budget or a 10-month schedule. These documents provide the scale against which probability and impact are measured. 6. Other planning documents, such as scope, schedule, and cost baselines. All these documents provide context for probability. Understanding the complexity of the work packages obtained from the work breakdown structure, the tightness of the schedule, or the leeway in the budget helps experts judge the likelihood of risks occurring. How can a poor project documents analysis harm the PMBOK Perform Qualitative Risk Analysis process? A poor analysis of project documents is a critical vulnerability in the Perform Qualitative Risk Analysis process, as it directly undermines the foundational inputs required for effective risk assessment. According to PMBOK principles, Perform qualitative risk analysis depends heavily on accurate and comprehensive inputs. Poor document analysis corrupts these inputs, leading to a flawed process as follows. 1. Incomplete risk identification, or garbage in, garbage out. The qualitative analysis process assesses risks already identified. If document analysis is poor, you can have: first, missed risks. Key risks embedded in the scope statement, requirements documentation, assumption log, or technical specifications may never be identified in the first place. Second, superficial risks. Risks are only identified at a high level, missing nuanced triggers and secondary effects described in detailed plans. As a result, the qualitative analysis is performed on an incomplete risk list, creating a false sense of security. 2. Inaccurate probability and impact assessment. This is the core of the process. Poor document analysis leads to: first, faulty context. Without a clear understanding of the schedule obtained from the schedule baseline, budget obtained from the cost baseline, and technical requirements, the team cannot accurately judge how likely a risk is or what its true impact on objectives would be. Second, misguided scoring. A risk might be scored as high impact on cost. But if the cost baseline analysis was poor, the team might be wrong about the available contingency or cost sensitivity. As a result, the risk scores, or probability X impact, are unreliable. High-priority risks may be deprioritized, and trivial risks may consume disproportionate management attention. 3. Compromised risk categorization. As categorizing risks, for example, by source, WBS area, or RBS, helps identify patterns. Poorly analyzed work breakdown structure or project scope statement leads to misassignment of risks, making it impossible to see that, for example, 60% of high-priority risks originate from a specific subcontractor's work package. As a result, the root cause analysis is flawed, and risk response planning is inefficient, targeting symptoms rather than concentrated problem areas. 4. Invalid assumptions as risk drivers. As the assumption log is a primary risk source, poor analysis means: first, uncritical acceptance. Underlying high-impact assumptions are not challenged or explored for instability. Second, missed constraints. Constraints documented in the project charter are not evaluated for the risks they impose. As a result, the risk register fails to include risks stemming from invalidated assumptions, which are often the ones that cause major project failures. 5. Ineffective and untraceable risk urgency assessment. The urgency dimension, or near-term risks response, requires understanding the project timeline and milestones. Poor analysis of the schedule baseline means the team cannot accurately determine if a risk's trigger is imminent in the next phase or distant. As a result, a high-impact, high-probability risk that is imminent may not be flagged as urgent, delaying response planning until it's too late. 6. Biased and uninformed expert judgment. The process relies on expert judgment. Poorly analyzed documents mean: first, experts operate with bad data. Even the best experts will give flawed opinions if their foundational information, the applied documents, is misinterpreted or incomplete. Segundo, stakeholder bias dominates. In the absence of solid documentary evidence, subjective opinions, political influence, and cognitive biases fill the void. As a result, the qualitative analysis becomes an exercise in group opinion rather than a structured assessment grounded in project reality. In the PMBOK framework, Perform Qualitative Risk Analysis is fundamentally a process of information synthesis. It draws upon raw data from project documents, particularly the risk register, assumptions, stakeholder concerns, and project objectives, and applies expert judgment and assessment tools to transform that data into a prioritized list of risks. The quality, currency, and completeness of the relevant project documents directly determine the validity and usefulness of the outputs of qualitative risk analysis. These documents serve as the indispensable foundation for the process. What happens without robust project document input? First, the analysis becomes generic. Risks are evaluated based on gut feeling rather than project specifics. Second, poor prioritization. You might misclassify a high-impact risk as low, or vice versa, leading to misallocated contingency resources. Third, lack of credibility. The risk ranking will not resonate with stakeholders or align with known project challenges. Fourth, ineffective risk responses. Prioritization drives response planning. If prioritization is flawed, you will develop responses for the wrong risks. In conclusion, rigorous project documents analysis is not a separate administrative task, it is a prerequisite for credible risk management. It ensures the qualitative risk analysis is grounded in the project's true structure, constraints, and requirements, allowing for proactive and effective risk management. Conversely, Perform Qualitative Risk Analysis is crippled by poor inputs. Its key outputs, such as prioritized risks, risk categorization, and risk urgency assessment, are all rendered unreliable. This, in turn, corrupts downstream processes. First, Perform Quantitative Risk Analysis is based on a flawed priority list. Second, Plan Risk Responses wastes effort on the wrong risks. Third, overall project risk exposure is misrepresented to stakeholders. How important is the input of enterprise environmental factors to the Perform Qualitative Risk Analysis process? The input of enterprise environmental factors is critically important to the Perform Qualitative Risk Analysis process. It is not just one input among many. It fundamentally shapes how risks are assessed, prioritized, and perceived. Here's a breakdown of its importance, moving from general to specific impacts. 1. Enterprise environmental factors set the lens through which all risks are viewed. Qualitative analysis is about subjective judgment, probability, and impact. Enterprise environmental factors provide the context that shapes that subjectivity for the project team and stakeholders. First, organizational culture and risk appetite. A risk-averse organization, for example, in pharmaceuticals or aerospace, will rate a moderate risk as high. A startup in a fast-moving tech sector might rate the same risk as low, accepting it for greater reward. Second, stakeholder risk tolerance. This is a direct enterprise environmental factors. It dictates the thresholds for what is considered a high or low risk on the probability and impact matrix. 2. Enterprise environmental factors directly influence the risk assessment criteria. The process uses a probability and impact matrix, which is often predefined at an organizational level. Being an enterprise environmental factor. First, tailored scales. An IT company and a construction company will have completely different definitions of a high financial impact, for example, $100,000 versus $10 million. These scales come from organizational standards, which are the enterprise environmental factors. Second, risk categorization. How risks are grouped, for example, technical, external, or organizational, is often influenced by industry standards and organizational governance frameworks, which are the enterprise environmental factors. 3. Enterprise environmental factors provide critical data for risk identification and assessment. Many enterprise environmental factors are direct sources of common or industry-specific risks. First, market conditions, competitor activity, market volatility, or currency fluctuations are external enterprise environmental factors that generate risks. Second, government or industry standards, new regulations, compliance requirements, or safety standards, which are enterprise environmental factors, introduce risks of non-compliance or mandatory changes. Third, commercial databases, access to industry risk databases, academic studies, or benchmarking data, which is an enterprise environmental factor, provides objective baselines for judging probability and impact. Fourth, geopolitical climate, political instability, trade policies, or regional conflicts, which are enterprise environmental factors, are critical for assessing external risks. 4. Enterprise environmental factors enable or constrain the process itself. First, tools and systems, the availability of risk management software, collaborative platforms, or historical records. All enterprise environmental factors determines the sophistication and efficiency of the analysis. Second, personnel capability, the existing project team's experience with risk analysis, which is an enterprise environmental factor, affects the quality of the judgments made. A less experienced team may need more guidance, skewing results. How can a poor enterprise environmental factors analysis harm the Perform Qualitative Risk Analysis process? A poor or inadequate enterprise environmental factors analysis can significantly undermine the Perform Qualitative Risk Analysis process in several critical ways, leading to a risk assessment that is misaligned with reality and of limited value. Here's how a poor enterprise environmental factors analysis causes harm, broken down by its key components. 1. Misidentification and omission of risks. Poor understanding of culture and governance. If the analysis fails to grasp the organization's real risk appetite, tolerance, and cultural resistance to change, the project team may, first, overlook cultural risks. For example, not identifying risks related to stakeholder resistance in a hierarchical organization. Second, miscategorize risks, labeling a high-impact risk as low, because the company's stated, but not actual, risk appetite is high. Ignoring market conditions and external factors. Without analyzing enterprise environmental factors like industry standards, competitor actions, or regulatory trends, the team misses critical external threats, for example, new compliance laws or opportunities. Neglecting infrastructure and resource ecosystems. A poor analysis of existing systems, physical infrastructure, and supply chain maturity can lead to missing risks related to system incompatibility, logistical bottlenecks, or supplier instability. 2. Inaccurate risk probability and impact assessment. This is the most direct harm. Qualitative analysis relies on rating probability and impact, often using predefined scales. Poor enterprise environmental factors data corrupts this at the source. First, faulty scales and benchmarks. If the impact scale, for example, high equals greater than $1 million cost overrun, isn't calibrated to the organization's actual financial condition, which is a key enterprise environmental factors, a risk's impact will be misjudged. Second, lack of historical context. Enterprise environmental factors include historical information and lessons learned. Without this, the team cannot accurately judge the likelihood of recurring issues. For example, vendor X is always late in our climate. Third, misjudging operational capabilities. overestimating the team's skill levels, which is an internal enterprise environmental factors, or the reliability of existing software platforms can lead to underestimating the probability of technical failure. 3. Ineffective and biased risk prioritization. The goal of qualitative analysis is to prioritize risks for further action. Poor enterprise environmental factors skew this prioritization. First, the echo chamber effect. Without a structured analysis of external data, the scoring relies too heavily on the personal experience and cognitive biases of the team members, rather than objective environmental factors. Second, creating a false sense of security. Risks that are actually severe in the context of the organization's fragile market position might be deprioritized. Conversely, minor risks might be exaggerated based on internal politics, as an unexamined enterprise environmental factors, rather than true business impact. 4. Undermined credibility and stakeholder engagement. First, stakeholder distrust. Savvy stakeholders, especially sponsors and functional managers, will recognize when the risk assessment doesn't reflect the organizational realities they operate in daily. This leads to loss of credibility for the PM and the process. Second, poor risk communication. You cannot effectively communicate why a risk is high priority if you cannot link it to concrete environmental factors, such as this regulatory risk is high because our enterprise environmental factors analysis shows the regulator is increasing audits in our sector. 5. Inefficient resource allocation. Ultimately, qualitative risk analysis guides where to apply limited risk response resources, such as time, money, and people. A poor enterprise environmental factors analysis causes misallocation. First, resources wasted on responding to risks that are unlikely or low impact in the true environment. Second, critical exposures are left unaddressed because the risks were not identified or under-prioritized, potentially leading to project failure. In conclusion, enterprise environmental factors are the essential background against which the qualitative risk analysis picture is drawn. Enterprise environmental factors anchor the subjective assessments in organizational and external reality. Enterprise environmental factors standardize the assessment so risks are prioritized consistently across projects. Enterprise environmental factors inform the team about broader conditions that create or exacerbate risks. Enterprise environmental factors calibrate the tool, like the probability impact matrix, to the organization's unique environment. In summary, neglecting enterprise environmental factors in Perform Qualitative Risk Analysis would render the process myopic and theoretical. The output, which is the prioritized risk register, would not reflect the true organizational and environmental context, leading to poor decision-making and resource allocation for risk responses. It is a foundational input. In essence, enterprise environmental factors are the reality check for qualitative risk analysis. They provide the essential context against which risks are identified, evaluated, and ranked. A poor enterprise environmental factors analysis decouples the risk process from the ground truth of the organization and its ecosystem, rendering the qualitative analysis an academic exercise that fails to protect and guide the project effectively. It turns risk management into a paperwork drill rather than a strategic tool. How important is the input of organizational process assets to the Perform Qualitative Risk Analysis process? This gets to the heart of how mature organizations manage risk efficiently. The input of organizational process assets is critically important and foundational to the Perform Qualitative Risk Analysis process. It is not just another input. It is what allows the process to be consistent, efficient, and aligned with the organization's risk appetite and culture. Here's a breakdown of why and how organizational process assets are so crucial. 1. Provides the methodology and framework. First, risk management plan template. Often part of organizational process assets, this provides the predefined framework for how qualitative analysis will be conducted. Second, risk categories, such as risk breakdown structure, or RBS. A standard RBS stored as an organizational process assets ensures risks are categorized consistently across all projects, making analysis and reporting more coherent. Third, definitions of probability and impact. Organizational process assets contain the organization's standardized probability and impact scales, for example, a 1 to 5 scale with clear definitions for what high, medium, and low mean for cost, schedule, scope, and quality. Without this, each project manager would invent their own, making cross-project comparisons impossible. 2. Enables consistency and comparability. First, predefined probability and impact matrix. This is arguably the most vital organizational process assets for this process. The matrix, a lookup table, dictates how the combination of probability and impact ratings translates into an overall risk score and priority level, for example, high, medium, low. Using a standard matrix ensures a risk rated high on one project means the same thing on another. Second, risk prioritization criteria. Stored policies define what makes a risk high priority beyond just the score. Perhaps all risks with legal implications are automatically elevated. 3. Improves efficiency and leverages historical knowledge. First, lessons learned repository, historical risk registers. Past projects identified risks and their analysis outcomes are invaluable organizational process assets. They allow the current project team to quickly identify recurring or similar risks. They allow the current project team to see how similar risks were assessed and handled. They also allow the current project team to avoid repeating past mistakes. This organizational memory dramatically speeds up the analysis process. Second, templates. Standard risk register templates and risk report formats save time and ensure all necessary information is captured. 4. Embodies organizational risk culture and appetite. First, risk management policies and procedures. These formal organizational process assets dictate the mandatory steps, roles, and responsibilities for risk analysis, ensuring governance compliance. Second, stakeholder risk tolerance levels. Understanding the organization's and key stakeholders' appetite for risk, or what level of risk is acceptable, is embedded in organizational process assets. This tolerance directly influences the design of the probability impact matrix and the thresholds for risk responses. How can a poor organizational process assets analysis harm the Perform Qualitative Risk Analysis process? A poor analysis of organizational process assets can significantly undermine the effectiveness of the Perform Qualitative Risk Analysis process, leading to flawed risk prioritization and poor decision-making. Here's how this occurs. 1. Inaccurate risk probability and impact assessment. First, flawed historical data. Organizational process assets include historical risk registers and lessons learned. If these are poorly analyzed or outdated, the project team may misjudge the likelihood or impact of similar recurring risks, either overestimating minor risks or underestimating major ones. Second, biased assessments. Without a proper review of past projects' risk ratings, the team relies on personal or group bias, leading to inconsistent and subjective evaluations. 2. Ineffective risk categorization. Poor risk breakdown structure, or RBS. An organizational process asset often contains a standard risk breakdown structure. A poor analysis means using an irrelevant or poorly structured RBS, causing risks to be categorized incorrectly. This hampers identifying common root causes and allocating appropriate management focus. 3. Unreliable prioritization, or poor risk scores and ranking. Non-standardized scoring. Organizational process assets provide predefined probability and impact matrices scales. If these are not properly analyzed and tailored to the project context, the team may use inappropriate scales, for example, a scale for construction projects applied to a software project. This results in meaningless risk scores and distorted risk rankings, directing attention to the wrong risks. 4. Weak risk urgency and trend identification. Missed patterns. Past risk data can reveal patterns. Certain risks tend to materialize in specific phases. Poor analysis misses these trends, preventing proactive management of urgent risks or risks with near-term triggers. 5. Inefficient use of expertise. Ignored stakeholder lists and expertise. Organizational process assets include lists of subject matter experts and stakeholder registers. Failing to analyze these means not engaging the right experts for risk interviews or workshops, leading to shallow risk analysis without critical insights. 6. Inconsistent definitions and communication. Lack of common language. Organizational process assets establish standard risk terminology and reporting formats. Poor analysis leads to inconsistent definitions of terms like high probability or major impact across the team, causing confusion and miscommunication about risk priorities. 7. Missed opportunities for efficiency. Reinventing the wheel. Teams waste time developing risk categories, matrices, and approaches from scratch rather than adapting proven templates and processes from past projects, slowing down the analysis and introducing avoidable errors. In essence, organizational process assets provide the calibrated instruments and historical maps for risk analysis. A poor analysis means navigating project risks with a broken compass and an inaccurate map, significantly increasing the chance of being blindsided by issues that could have been foreseen and managed. Consequences of weak or non-existent organizational process assets. If an organization has poor or no relevant organizational process assets, the Perform Qualitative Risk Analysis process becomes: first, subjective, heavily dependent on the project manager's personal experience and judgment. Second, inconsistent, risks cannot be compared across projects, and portfolio-level risk management becomes meaningless. Third, inefficient, every project starts from scratch, reinventing scales and matrices. Fourth, less credible. Decisions made from the analysis may be questioned due to a lack of a standardized, approved basis. Consequences for the project. First, misallocated resources. Time and money are spent managing low-priority risks while high-impact threats are neglected. Second, false sense of security. The project team may believe major risks are low priority and be unprepared when they occur. Third, increased project vulnerability. Critical emerging risks are not identified early due to poor categorization and trend analysis. Fourth, stakeholder mistrust. Decisions appear arbitrary or poorly justified when risk priorities aren't based on organizational historical data and standards. In conclusion, Think of organizational process assets as the playbook or corporate knowledge base for qualitative risk analysis. They provide the rules, tools, templates, and historical data that transform an otherwise ad hoc, subjective discussion into a consistent, repeatable, and auditable business process. Therefore, the input of organizational process assets to perform qualitative risk analysis is not merely important, it is essential for the process to be effective and add value to the organization. This video is finished, but we will have in the next videos. 1. Creation of WBS for different projects using WBS Schedule Pro. 2. Examples of project plans using MS Project. And many more videos. Don't forget to give a thumbs up if you like this video and want us to continue with new topics. Subscribe to the channel. All content is free. You can also comment suggesting topics you would like to see on this channel. Thank you.